Moving into sheet metal, okay? Now, this is what's interesting. We have a new process in a command that has become more and more popular. And so for those of you that are sheet metal centric, and you're probably quite familiar with this, notice that I transferred from synchronous into ordered. That is because the command that's been enhanced is called the lofted flange. And the lofted flange, which is ordered, it is profile dependent, hence it is an ordered feature. And so notice effortlessly we switch back and forth a little bit. What is new or enhanced with the lofted flange is we have a new bending method, okay? And that bending method is meant to improve with great accuracy the flat pattern development on non-uniform bends. So most of you are probably doing tabs and flanges or contour flanges and so forth, and you might have some angle to your flanges or maybe not, and those are as always pretty straightforward and very predictable, and after a little time you can get a flat pattern that is geared very much towards your press or towards your machinery, and with decent accuracy or acceptable accuracy. For those non-uniform type situations like a lofted flange, we'll do something called new triangulation to develop the bends. Let me demonstrate. So in this situation, I simply want to say, well, I'm going to go from this profile, accept. Everybody forgets to accept. Don't pick both. Pick one and accept. There, a little bit of free training right there. See, makes today worth it. Then we pick the second, and you'll notice that it shoots a point to point, okay? Those are called vertex maps. And you can add vertex maps, the more difficult. Remember, this is sheet metal. Sheet metal doesn't morph, okay? This is not plastic. This is not a machine part. This is not a forge or anything like that. Sheet metal bends, and that's about it. It bends and stretches and compresses in a very rigid fashion. So we have to account for that and try and give you a little bit of flexibility. So with that, they introduce vertex maps, where you can set up point-to-point maps and add greater predictability to your end result. We'll take that material to the inside of our shape. And for those of you that might have done this in the past, you'll notice that is a little bit more involved, yes, but it is far more realistic, because to make a shape like that, that has to be fed, bent, fed, bent, fed, bent, and etc., unless it is rolled on a special tool. There again, to get the flat pattern correct, you're going to have the right information in what you're seeing here in this lofted feature. With that came a new bend table. And the bend table, which is very centric to what we just did, this is fairly involved. Okay, back in the day, it was one bend of a total angle. Now we have angle and included angles, okay? The flip side angle, if you will. And also we're tied to which particular bend. This is very important for anybody that has actually bent metal and fabricated metal, which yours truly did at a much, much younger age to get himself through school. We're going back in time on y'all. So there are certain bends that are more problematic than others. And now we can break this down and decipher each bend, and you'll notice picking an entry is going to highlight where that entry is on your model, and you can actually then work that single entry with great accuracy versus the old days when it basically just created one non-uniform bend and you had to work with it from that point. So a nice addition, I believe, in the sheet metal world here, okay? So I'll hit OK here. I'll accept what it has built for me. A lot of folks wonder about, well, what are we doing with that? Well, actually, you're always in sheet metal. It's an open piece. This would actually be brought in and mirrored over. You'd mirror copy a part, and we would mirror the entire body, for instance, and we would do something pretty nifty like say, well, what I'm going to do is mirror that with a little gap, because I'm either going to weld or spot weld or put some seams or mounting tabs in there. So I'm going to give myself just a little bit of breathing room and say I want to mirror that down and probably put a seam in there, something like that. That's a more generous theme, but you get the idea of what we're trying to do, and then decide how you're going to adhere those, if not slip fits or notches or something like that. At any rate, a lot of people ask, well, you only built half of it. Yes, I'm going to let the system build the rest here for me, and then pull flanges off for mounting and so on, okay, from there. So the first question, I'm sure everybody who does Shimano is saying, you got to unfold that, right? How does it unfold? What does it look like? Well, you're right. I do have to unfold that. So real quick, let's go into tools and we'll flatten that out. Okay. Now, for those of you that are not typically doing any flat patterns, or you are, be advised that the flat pattern treatments are here. This is a major time saver, right? Outside and inside corner treatments, whether it's for safety or ergonomics, sometimes you got to go ahead and break those corners, and instead of you picking every corner on there and saying chamfer, 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 and so on, let the system do that for you as it's creating the flat where it counts, because it's that flat that you're going to nest and cut, and that's where those breaks are going to happen on the corners. So there's a little bit of automation built in for you. There's also cut size defaults, and the reason I'm talking about this is that later, before we wrap up, I'll be able to talk and show you a little about the new nesting product that is coming with 2020, or has come out with 2020, I should say, pardon me. And with that, then our cut size default values, a max and a min, max in the X and the Y, becomes very important, because the amount of material or the amount of pieces you can nest in one sheet in one run then has some serious cost and advantages to it, the more you can work on that. So this is sort of a seed bit of information that leads us into the nesting process. Furthermore on that, you can come in with and this is not new, but it is very important, we can actually set an alarm if we exceed a given length and a width on the cut size. We can pop up an alarm, and so you would violate your own design criteria in the flat without even having it flat. You can set this up and work on the formed model, and it would tell you, hey, in the flat, that's going to exceed your own criteria. So very handy. Good stuff there for you. So we would pick on I'm going to flip this around and pop that. Then you'll notice, whoop, my bad here. That's the mirror. I'll move on, but I'll come back if anybody's totally interested in that, and we'll flatten that out, remove the mirror, and so on. I'm sure that is what's bothering that